Okay, guys, back to matching piecewise functions to their graph. So we're going to pay attention to whether they're linear, positive, whether they're negative, whether they're quadratics. We're looking at the domains that are set, open circles, closed circles, things of that nature. Also, you could also plug this in Desmos and it'll graph it for you and you can help differentiate that way. Without Desmos and just understanding the parts of piecewise, our first function here, we have a 4. So that means it's going to be y equals 4. Y equals 4 is a horizontal line, flat, which is what we have here. All 4 choices have a horizontal line that cross at that y value 4. Perfect. X is less than -1. So that means that line needs to only exist to the left of -1 and not have a solid circle because there is no equal to. So this solid circle is going to be our problem here, and this solid circle is here. So these two guys are out. Looking at our second function, we have 3 minus 5x. Most of us back in Math 1 and those beginning classes with linear function liked it in the y equals mx plus b form instead of out of order. So that negative 5x means our slope is -5, which means reading from the left to the right. So looking from left to right in this direction, that second function in the middle needs to go down. Needs to be a negative line. So we're looking from -1 to 3/5, so not quite to 1. So from -1 to 3/5, going this way, this line needs to go down. Looks perfect here. Solid circle at -1 because that equal to is great. Less than, so an open circle on the next end looks good here. Our problem with this answer, our solid circle and our open circle is perfect, but this is a positive line. So that's not going to work for us. And if that didn't pick up for you enough, if we look at our third function, we have 2/3 x. So this is a positive slope for that linear line. So our third line needs to be increasing, not decreasing. This guy is decreasing right here. So we want to make sure it's going up. So our answer is going to be this one. All right, a couple more. Ready? All right, so we're going to evaluate the function at the specified input of 4. So what works for x equals 4? Looking at our domains, is 4 less than 3? It is not. Does 4 fall between 3 and 10? It does. Let's just make sure. Is 4 greater than 10? It is not. So we are going to use our second function because 4 does fall between 3 and 10. And we're going to plug it in. So 4 squared minus 7. 4 squared is 4 times 4, which is 16, minus 7. So our answer is going to be 9. I challenge you to stop a moment and pause and see if you can do this next one now. Because again, starred, it is an EOC release style question. You need to be able to do this by the end of the semester because we are going to kick this EOC's butt. All right, h of -4, we're in our h function, We're looking for which one -4 fits. They both have -4s, so again, we're looking for that equal to, because -4 is not less than, but it is equal to -4, and -4 is not greater than -4. So we're going to use our first function, which is -1/2 times a -4 minus 15. So we're going to solve that. Then we're going to add it to 3 times whatever goodness we get to do with our next h of -2. So h of -2, is -2 less than or equal to -4, or is -2 greater than -4? -2 is greater than -4 because it is to the right on the number line. So we're going to use our second function here. So 20 minus 3 times a -4 squared. The x is taken out, does not exist anymore because it is telling you, mistake, this is a -2. Sorry. -2, because it's -2 here. That was my mistake. And then we're going to solve from there. So a -1/2 of a -4. Multiplying by 1/2 is the same thing as dividing by 2. And a negative is going to give me a positive. So it's going to be a +2, because 4 divided by 2 is 2, minus 15. I'm going to scoot up here to the top. Gives me a -13. If I have $2 and I spend 15, I owe somebody 13. So we're going to do plus 3 times. -2 squared is a +4, because a negative times a negative is going to give me that +4. We're going to multiply that by -3, and we're going to get a -12. So 20 minus 12 is going to give me 8. So 3 times 8, so we have -13 plus 24. And then we're going to solve negative 13 plus 24. So I have $24 because it's positive, and I spend 13 because it's negative, means that I have a positive 11 for my solution. Last but not least, hopefully you can see this guy looks kind of tiny. I tried to squeeze him in there. So in the piecewise function above, what does the domain for x plus 5 squared minus 4 mean? So like the other day when we did this video prior, another video with this style problem, x is not equal to negative 2. The second one is x is equal to negative 2. So that means for the second function, negative 2 is the only domain or x value that will work for the output of 4. X is not equal to negative 2 means it could be any number under the sun other than negative 2. So only values larger than negative 2 is not right, because that would be x is greater than negative 2. Only value smaller than negative 2 is our second choice. X is less than negative 2, which is not what it says. Any value other than negative 2 will apply to this function. So anything other than negative 2, so as long as it is not equal to negative 2, this one looks good. But just for good measure, we're going to make sure we check the other one. Only the value negative 2 will apply to this function. And that last one is that x equals negative 2. Hopefully that guy wasn't a big deal, and that was pretty easy. It is some reading. Please, again, reach out. Piecewise functions will be on your EOC. They are very important, and I am here to help, guys. So let me know what I can do to make things easier for you.